Hello, I'm Roberto. In this session I want to explain how to achieve high concurrency and scalability in your application using cloud computing and Microsoft Azure. Well, as you probably know, heavy workloads are memory intensive, IO intensive, and CPU intensive from the computer perspective, from the server perspective. Okay, so a resource can be affected, and that resource can be the memory. So, for example, if you perform some high performance computing with huge data sets that should stay in memory for the entire operation, you should have so much memory to do that. Another kind of operation is the IO intensive one. So if you have to download, upload, so if you have a network stream it's so intensive, you should probably need a network that can handle this, okay? And you can probably scale out to with the IO, so with the throughput of your network storage, with your disks and so on. And finally, if you have to process some images, some resources, some calculation, you should probably fall into this third category of CPU intensive operation, and this is the one we are going to experiment today. So today the scenario is a simple application that produces some complex math operation. Okay, so this is taken from the real world solution, but it's been simplified to be consistent into a 30-minute or 55-minute session. So the producer is typically producing an operation, a message that represents a math operation sum, okay, between two numbers. So it's not really difficult, but to simulate this time to complete this operation, we just introduce a sleep into our code. So when the consumer processes the message, it of course it processes also the math operation, but it will also add a delay, a simulation delay to the operation, just to be similar to the real example, okay? And the third building block is not really relevant for this demo, but just optional. It's just the viewer part that displays the result, okay? So we want to enqueue a huge number of messages, and we want to consume them as soon as possible, okay? So we want to scale out to many machines, to many cores, okay, to process the service bus messages as fast as possible, okay? To do that, we are going to use just platform as a service products with Microsoft Azure. We have some code written in .NET to perform the operation, and we are going to provision all the resources right now. So first one can be the service bus. That's a message broker that let us send message to a queue and also consume messages to that queue. Another building block is the storage account. In Microsoft Azure terminology, a storage account is the place when you place blobs, so files, okay, and some other artifact that we are not going to discuss in this session, okay. Another building block is the batch account. So batch is the underlying technology we are going to use to scale out with a huge number of machines. So batch is something that is in the middle between platform as a service and infrastructure as a service. So what I mean is that with infrastructure as a service, you have to deal with your machines to connect to the VMs, to update them and so on. While in batch, you're just defining your machine type, and then batch takes the control, the complete governance around your instances, so you don't have to start them, patch them, install something on them. So it's quite, it's almost automatically, okay? So I personally define Azure Batch something in the middle between infrastructure as a service and platform as a service, because you can see the underlying machines that you are going to create. So this is just my opinion about that, of course. And finally, just to define which is the VM and the runtimes and the code that will execute to consume our messages, we are going to create a VM, a simple VM, just to be used as a template, okay, not with the capability to run our workload, just to define the type, the templates, the runtime, and then we will throw it back to Azure. So let's start the demo part. We start almost from scratch. Why almost? Because we just need an image definition that is already written into a specific storage, because it's an operation that will complete in around 50 minutes, and we don't have that time in this session. So let's start by creating our resources. The first one is the storage account. We have many types of storage account. The one we need is the storage v2 general purpose. That is a type that can hold blobs, so files, and we are naming it net summit billers. Okay. The region is this one. This is the pricing tier. The differences between this tier are the pricing, of course, and the features. So, for example, this one is geo-replicated across region and also read access available. This one is the cheapest one and is just redundant inside the area, the zone of the data center, for example. We can define the protection, so if the storage account can be accessed from outside or not, and many other features that we are not going to discuss in this session. And let's create this first building block. Okay, it's validating the inputs probably. Okay, in the meantime, we create the second one. That's the service bus. Okay, the service bus, it's a message broker. If you are familiar with messaging technologies, just the equivalent of like something like RabbitMQ on Azure Stack, and not really like a RabbitMQ, but it's AMQP compliant. So you can, of course, connect to it with .NET and many libraries in any other language, of course. Boris. Okay, I'm going to create it in the same data center that I created the storage account to. I say standard. The difference between tiers in the service bus are the topics support, so the standard supports topic and the basic not, and this premium one is so expensive compared to this one because it's a complete different technology under the hood. So if you need a real heavy workload in production, you should probably go with the premium account. In this case, of course, standards is quite enough. Okay, I'm going to create the service bus too, and also the storage account in this other tab. And now I'm going to create the batch account. Batch account is just a container. Batch accountee, no, batch account. Oh, okay, good. Batch service. It's just like a container of machine pools. It's not just itself something that is attached to a pricing. Okay, so batch it's like a free service, but you will be billed based on the VMs that this batch account will provision when you say so for your workloads. Okay, so the batch account itself, it doesn't cost anything. Okay, so net summit belarus.northeuro batch azure.com. Okay, and I will select the storage account to save some diagnostic data. Okay, this is an important step. Okay, when you select this pool allocation mode batch service, the VMs, so the machines, are automatically provisioned by Azure, and they are not visible in your subscription, so you're just paying for the computation. Okay, this is the most recommended approach in my opinion, because it's very PaaS, it's very platform as a service. But since this mode needs you to open a ticket to increase the quota, the consumption of the total CPU of your subscription to Microsoft. So for this demo, for example, I need something like 100 instances, and I will need to open a ticket to Microsoft to increase my default numbers to 100. Okay, I'm gonna use the user subscription mode. That is a mode that will instantiate the VMs inside my subscription. So I will see the VMs that Azure Batch will provision for my workloads. Okay, it's really equivalent. Okay, so the effect is the same, but I prefer to not have this kind of stuff into my subscription. I just want to be cleaner. So forgive me if I use this mode in this session, just for to be in time. Okay. Okay, last one is the Linux VM that I'm going to use to customize my operating system, install libraries, and prepare a machine that can run a .NET Core workload. Okay, so I create a VM into this resource group. Well, resource group is just a container of resources, a logical container of resources. I will create .NET Summit Belarus machine in North Europe. I will use not the most recent one, but it's not just because my scripts are well defined with this version. Is not there are any other motivation about that, and the sites is really irrelevant because I'm going to use this machine for just 10 minutes, so I can choose any size and it's not a problem. I will enter a password just to be to avoid to have SSH certificates and so on. So I will say net summit admin password. This one, okay, I generated this one in a notepad in my second monitor. I attach the default disk that is premium SSD. I attach the default virtual network, and I also enable some guest diagnostics to my storage account, and then I will confirm the creation and going ahead. Okay, so in 5 minutes probably I have this virtual machine created to be customized further. Well, my first set of resources have been created, so we created a storage account that will hold some diagnostic stuff, but also our binaries that we are going to build right now. We created the service bus that will hold the messaging technology. We created the batch account that will hold the all the machines that will perform the computation, and we are creating the Linux VM that we are going to use to create the image definition, the template for our workload machine. Okay. Well, let's go to the service bus a second. So, service bus. This one, I also pin this to my dashboard. At the beginning I don't have any queues, any topics, so the difference between the two are that the queue is the most simpler one, is the first in, first out queue, while the topic is the publish subscribe model. So in this session, to be faster, we are going to use the queues instead of the topics. The first one can be the to-do queue, so the items to be consumed, okay? And we can also create a second queue for the results. So when the consumer processes the message into the to-do queue, it can also forward the result to the result queue. This can be the pattern, okay? The service bus has many methods to authenticate against, and the most simpler one for this session is to use the root manage access key. It's not the most convenient or the suggested approach in production because it's just the root access, so you can define a specific access for a specific queue just for listening or just for sending, but in this case is really the fastest option. Okay, I copy into my clipboard, and now we are switching to Visual Studio. Okay, in this solution we have the producer. That's just a simple task that instantiate a Q client. This library is Microsoft Azure Service Bus library that is written against .NET Core, .NET Standard, if I remember correctly, yes. And it's connecting to a connection to a specific queue. So we are going to create the connection, and the queue names are those ones. It's okay. After that, it's generating while true, so infinitely, some messages to the queue. So let's run this task, and we are generating some messages. Okay, so probably we're just a couple of hundred right now, but we're running it for a while just to insert 3,000 messages or so on. Okay. In the meantime, we take a look to the consumer task. This has some boilerplate code. This receiver is just a queue client itself that connects to the same service bus connection to the to-do queue, and the sender, it's another queue client that will send against the result queue. So now the logic is when a message arrives, I will split the content, that's a text content, into the two numbers. I will add the two numbers. I will introduce a fictitious delay to simulate the CPU processing time. Okay, and then I will send the result to the result queue. Okay, so simple. So let's go ahead. I can stop this one, and I can start the consumer process. As we can see, each message will take around 1 second. No, something is going wrong. Exception received. So let's see if everything is okay in naming. So results, result. Okay, it's just a naming issue. Okay, let's run again the consumer task. Okay, and each message takes around 1 second to go ahead. Good. So now we have the goal in our mind. The goal is to consume all those messages as fast as possible, because we need to scale out some resources to do that. If we go into the to-do queue, we see that now we have around 1,500 messages, so it will take around about 25 minutes to perform all the queue, so it's too much. So now let's proceed. Okay, so the VM should be provisioned right now. Okay, and we can connect to it with SSH, or we are just connecting with the serial console that is very, very fast and convenient. Okay, now it's asking me the credential. Okay, admin, and the password I take it from my notepad. Okay, and now I install .NET Core into this machine with a script that I have in my notepad. All the stuff, all the code, all the notes, this presentation is available on GitHub on my profile, and also on the event website, of course. So now it's installing the runtime, the .NET Core runtime, and after that I'm just verifying that everything is okay. Just wait probably a few seconds more. Okay, good. Let's see. .NET info. Okay, that's all. So we can stop the machine. Alt. No. Okay. I'm not really a Linux guy, so forgive me. Okay. Stop it. Yes. Okay. Well, I created a Linux VM just to install my runtime. Now I stopped it, and after the VM is stopped, I capture the state of the disk to generalize an image that I can use to provision a huge number of machines, everyone with the same operating system and the same configuration. So each one with this image that I'm going to create. So I'm going to capturing the image, and I can also delay the virtual machine after I do that. So .NET Summit Belarus. Okay. After that, my image should be registered into an intermediate store that is called the Shared Image Gallery. The Shared Image Gallery is just a very convenient artifact to hold many different images in many different versions. So it's convenient when you provision some templates and you want to version them during time. So it's nice, of course, if you're going to start from scratch your solution. This can seem a little bit overkill, but you should take it into consideration because it's a very good approach to do that. My image is already uploaded it because it takes about 20 minutes to go ahead, so I just registered it before this session. Okay, but of course with the same approach I used to create the VM and install .NET Core inside it. Okay, so now we can go ahead with the batch account, not this one. So batch .NET Summit. Okay, and here I create a pool. Okay, a pool is just a definition of size of machine, a definition of a topology. Okay, so I define the pool number one as a pool with an image taken from my shared image gallery. The image is batch image version 1. The operating system is Linux with the Ubuntu with this version. Those are advanced configuration, and here it's the size. Okay, so the size is up to me. In my case, I don't want a huge machine in terms of CPUs and memory. I just want the cheapest one because I prefer to scale out with a several number of machines instead of having a less machine with a huge computation power. Okay, so I will choose this one. That is the cheaper one, about €25 per month actually and currently. So I don't know in the future, but this is the price right now. And I would say to scale to 100 nodes. Okay, good. I just reduced the resize timeout to be faster in this demo, but I will suggest you to investigate this timeout because it's very important to understand it before going in production. And I enable a startup task to check it out that the .NET framework is really installed. Okay, the startup task is something that you can also run to install some prerequisites on the virtual machine, on the machine, on the image, but I suggest you to prepare the machine as I did it before with a dedicated VM. So my startup task in this case is just a simple command line that in case everything is configured correctly, we return a result code that is interpreted as okay, good, go ahead. Instead, if you have a result code that is -1, for example, the startup task will run again up to 3 times in this case and if after 3 times is not exit correctly, this machine, the specific machine will not boot. Okay. This is a really important part. Okay. So I want that during the startup some resources are uploaded into the VM, into the actual instance that is provisioned at runtime. And which is this resource? Is the binary of my application. Okay, so the binary of my application is this one. Just a second. This one. Okay. So I want to upload all this stuff into some place that is shared between me and those instances. I can come back to the storage account here, and in the storage explorer I can create a container that is called batch, for instance, and inside it I upload those files. Okay. Good. Right now I'm going to say, hey, during the startup, go to that storage account and take all the contents of this container into the actual VM. And this operation is performed for each VM, of course, for each instance of the pool. Okay? The pool is now defined and is scaling up to 100 instances. Right now it's 0, but in a few minutes we will see a heat map with the instances that are booting, starting and running. But now we need to allocate some task to that pool, okay? And we can do this manually. Going here, create a job, and inside the job create a task for each operation that we want to perform. And in this case we need to create 100 tasks, each one with the command line that calls the consumer code. We don't want to do this manually, so what we can do is to automate this process with the Azure Management APIs. Okay, we have another step that is batch controller. This batch controller is using Microsoft Azure Batch library, that is the management library of Azure Batch, and the logic is pretty simple. I authenticate through against Azure, and I create a job. Inside that job I create a number of tasks that is equivalent of the number of the nodes of the pool that I just created, and then I commit that job. So with this code, with this script, I can create 100 tasks in just few seconds. Okay, how to do that? I said that I'm going to authenticate against Azure, but how? I need to go to Active Directory. I need to create an app registration like this one, for example, demos, and I need to create a client secret. Okay, it's not this case, so hold on a second. This is the demo effect, so I need another profile that has the appropriate authorization to do that. Oh, so hold on a second. I just create an application. Okay, so let's refresh this one. Okay, and now I have this entity that can log in, that acts as like a service account to my subscription. So now I just need to go to the subscription, or just the service in case, but in this case I can go here. I can go into the access control and add the role assignment to my .NET entity that I just created. Also this part I'm going to perform through my administrative account. Okay. And now I have .NET Summit here. So I can use the client key that I just took from the portal and the ID taken here. Okay. Now I can run this code. I can also debug it. Okay. With this line I got the pool with the pool name pool01. We create the job, and then for each node, that is 100, I create some tasks. I go ahead. Now I can come back here, come back to the batch account, come back here to the pools. I can see the job created automatically with the script, with the 100 tasks that are running. What does it mean? That the task has been assigned to an instance. In that case, this one has been assigned to this node, this specific node. This name is quite impossible to read because the VM name is auto-generated by the batch account. So if I go here, I can see the single node, I can see the specific file system of this node. So for example, you can go in through the standard output to see what's happening inside that. Okay, and I'm going to go here into the pool, and this is the situation. Every one of the 100 nodes are actually running and consuming messages. We can go to the service bus to see if there are some updates. So let's go to the service bus. Let's go to see the to-do queue, and it's empty. So in this few minutes, seconds, I don't know how many, all the messages have been processed and forwarded with the results, of course, to the result queue. If we want to see some output, we can go into a single machine and we can download the standard output, and we can collect the logs, and we can build on top of that our enterprise solution. Okay, so just to recap what we saw in this session, we saw that we can achieve a high concurrency, a very high concurrency rate if we use a service named Azure Batch that is just a facilitator that creates a huge number of virtual machines, everyone equal to each other based on a template, in this case a Linux VM template, and the instance will run our workloads, in this case a .NET Core application that is hosted into a storage account. So in real world, I really suggest to use this approach if you have, for example, some processing, to some graphical processing, some rendering, some we use in production because we have a company that processes a huge amount of data both in real time and also in batch, and in this case will help us to process a million of messages in about hours instead of weeks and months. So I hope you appreciate the session. Now I can answer your question, and I'm here to do that. Thank you very much.